Okay, Assalamualaikum and salam sejahtera to everyone. Okay, so this is our first video for the chapter 4. The title for the chapter 4 is Engineering Materials. So the times allocated for the chapter 4 should be in 10 hours of study time. Okay, so there are 4 subchapters. 4.1 Classification of Engineering Materials, and then 4.2 Plastics and Elastomer, Molecular Structures, Properties and Applications. 4.3 is about the ceramic structure, properties and applications. And last, the final subchapter of our syllabus is composite materials, types, properties and applications. Okay, so let's go to the 4.1 classification of engineering material. Okay, before we go deeper about chapter 4, I just want to remind you that the chapter 4 is more on the general knowledge, or you have to memorize most of the informations that we get in the chapter 4. Okay, so it is up to you how to study the chapter 4, but if you ask me, I can give you advice that you have to do the mind map per terminda, or you checklist, or you listing all the key point of the informations in the chapter 4, and then you summarize all the informations, and finally you can study easier. Okay, so this is just the introductions. So the classification of engineering materials, mostly about the metals, and then we have polymers and also ceramics. Okay, the relationship between properties, structure and processing. Okay, what we want to have in the properties of the materials, we process it and to get the structure of that material, and from the structure it will give you the properties that you want. Okay, so basically the properties is the outcome that you want based on the applications that where you want the material to be applied. Okay, so the next slide here, we already familiar about the objects of the metals and metals alloy, such as in this picture. This is the fork, knife, okay, scissors and so on. This is based on the metal materials. Okay, so the metal itself can be classified as ferrous or non-ferrous. Okay, ferrous where it contains ferrum. Ferrums mean iron. Okay, bersih. And non-ferrous where the material which the material does not contain ferrum element, does not contain iron element. Okay, so steel, stainless steel and cast irons all are ferrous metal, and aluminum, copper, titanium are non-ferrous metal. And then for the polymers, several common objects that are made of polymers materials, such as the plastic tableware, spoon, fork and knife, billiard balls, bicycle, helmet and so on. So mostly the materials that you found in our applications daily, which are based on the plastics, we call it polymers material. Okay, so for the metal here, we classify into two classification, which are ferrous and non-ferrous. And for the polymers, we classify as three terms. The first one is thermoplastics, second one is thermoset, and third one elastomers. Okay, uh, if you still remember, all these basics about the polymers are already, I think, have already covered in your chemistry subject in your secondary education, maybe form 4 or form 5. I think form 5, right? Okay, uh, so basically most of you have already known basic about the polymers. Okay, so the thermoplastic, some of the example are acrylics, nylon, PVC, polyethylene, and thermoset are epoxy resin, phenolic, polyester, and for the elastomers, there are rubbers, silicones, and polyurethanes. Okay, and then the third type of materials, the main type that I have mentioned earlier, is ceramics. So common objects that are made of ceramic materials, sometimes of kitchenware also can be based on the ceramics. And then we have a China teacup, yes, of course, of your teacups, your plate, your bowl, and most of them are ceramic based materials, a building brick, a floor tile, and a glass vase. So the classification of ceramics, okay, they can be in the oxides, where alumina, insulation, and abrasive, zirconia, dyes for metal extrusion, and abrasive. Okay, carbides or nitrides. Okay, so ceramics are compounds of metallic and non-metallic elements. So if you combine the metallic and non-metallic elements, you also can have the ceramic compounds. Okay, so uh, like I said, as an engineer, you have to know the applications of material science that we learn in the MEC281, because in designing a product, such as in this picture, a car as an example, there are many parts of the cars that be produced by different material. Okay, as an example, you can see here spark plug, which we use the ceramic, and the wiring here we use the copper. So copper is non-ferrous. And then we have plastic windshield here. This is the polymer. And then this is rubber tire. This is also the polymer. Steel frame is the metal. Okay, ferrous. And then so many parts, so many other parts in the car are based on different elements of materials. Okay, so that's why you have to study about the material science. Okay, and then this is just the examples of the materials in our daily life. Okay, uh, okay, next. Okay, and then we go deeper about the plastic and elastomers in the subchapter 4.2. Okay, the subtopic here is about the molecular structures, properties, and applications of plastic and elastomers. Okay, so in the end of this subtopic, you should be able to define the polymeric structure, describe the polymer chain, and also to differentiate between thermoset, thermoplastic, and elastomer. Okay, so we have three terms, right? Thermoset, thermoplastic, and elastomer. Okay, have you remember that? Thermoset, thermoplastic, and elastomer. Okay, wait for a second. I want to switch on my tablet to write down. So first term, second term, and the third term about the polymers. Okay, let's go to the introduction of polymers. Okay, polymers can be found naturally, okay, and also can be synthesized or can be as a synthetic. You can produce in the lab or produce in the manufacturing process. So that's what we call the synthetic. And then the naturally found in the environment in our planet, in our on our Earth, can be derived from plants or also animals. Okay, as example of wood, rubber, cotton, wool, leather, and silk. And other natural polymers are proteins, enzymes, starches, cellulose that can be found in the plant and also in the animals. Okay, synthetic polymers are the plastics, rubbers, and fibers. Rubbers here mean is the synthetic rubbers. Okay, and rubber here is the natural rubber that comes from the rubber plant. Okay, so to understand the chemistry of the polymer, we need to understand the definition of hydrocarbon. Okay, hydrocarbon is composed of hydrogen and carbon, H elements of carbon, and the C is the symbol of a carbon element. Okay, has covalent bonds for the intramolecular interatomic bonds, but for the intermolecules exit secondary bonds. Thus, these hydrocarbons have relatively low melting and boiling points. It also can be saturated and also unsaturated. Okay, so hydrocarbon may have different atomic arrangement, even though have some composition of isomerism. Okay, so even though have same composition, that we call it isomerism. So this is the term for the same composition. Okay, normal butane. So butane is Bu. Bu here is means 4. So there are 4 carbon. 1, 2, 3, 4. And then where we have A and E here, so it doesn't have double covalent bond, just a single covalent bond. So you only compare the C with the 3 here, and then uh, the free electron must be shared with another carbon. So you will get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So C4H10. So there is the chemical symbol for the butane. And isobutane, it also have similar composition of carbon and hydrogen to the butane, but this is the iso. It has the same composition, the isomerism, but in the different arrangement. Okay, right? So there are the isomerism between the normal butane and the isobutane. The difference are the arrangement of the composition, because this is just straight carbon and this one is the other carbon shared covalent bonding with the intermediate carbon atom here. So because of the different arrangement, the properties between them are also different. As example here, the boiling temperature for the normal butane is negative 0.5 degrees C. For the isobutane, the boiling temperature is negative 12.3 degrees C. Okay, so what is the definition of the saturated hydrocarbon here? The saturation just refers to the fact that each carbon bonded to 4 other atoms. Okay, all bonds are single and no new atoms may be joined without the removal of others that are already bonded. So the saturated means that uh, all the carbons is already bonded to 4 other atoms. Okay, so there is no possibility of another new atoms can join them without replacing the existing atom. Okay, so as example here, for the ethane, so this is already stable compound because there is no extra electron that can be shared, so it is already stable. So this is what we call it saturated hydrocarbon. Okay, so the composition and molecular structure for some of the paraffin compounds, CN, H2N plus 2. Okay, so for the methane, this is the structure of its atom arrangement. Okay, and then the boiling temperature here is minus 164. So naturally methanes found in the room temperature in gaseous state, dalam bentuk gas. Okay, for the ethane also minus 88.6 also found in the gaseous state during in the room temperature. Okay, so by increasing the number of carbon, the temperature of boiling point also increases. You can see the pattern here. Why? Because of more heat is needed to break the covalent bonding between them, when you have higher numbers of atoms between them. So that's why hexane here, it contains 6 carbon and 14 hydrogens. So there are more covalent bondings in that compound compared to the methane. So more heat is needed to break that covalent bonding, resulting to higher temperature of boiling point. Okay, so that is the general examples of saturated hydrocarbon. Okay, so let's go to the unsaturated hydrocarbon. Okay, molecules that have double or triple covalent bonds are termed unsaturated. Double or triple bonds between two carbon atoms involve sharing of 2 or 3 pairs of electrons respectively. Within molecules, atoms are bonded together by covalent interatomic bond. So, as example here, this is the triple covalent bond. This is the double covalent bond. Okay, so this when you have double or triple covalent bonds in that compound, so it automatically considered as unsaturated hydrocarbon. Okay, structure entities or part, a single mer is called a monomer. A monomer here. Okay, functionality, number of bonds that are given monomer can form by functional mer, 2 covalent bonds with another monomer forming 2D chain-like molecular structure. Trifunctional mer, 3 active bonds form 3D molecular network structure. Okay, can you see the pattern here? The bifunctional mer, bi is 2, so it contains 2 covalent bond with other monomer, right? And then 3 means that it has 3 active bonds that can form 3D molecular network structure. Okay, so this is the 3 functional mer. 1, 2, 3. Okay, this is the bifunctional mer. Okay, what is mer? Mer is a repeat unit, repeated along the chain. Monomer, monomer, so mono here. Small molecule from which polymer is synthesized. Polymer, many monomer that held together by covalent bond in a long chain. So poly means many, right? Mono means single. Okay, so in this case, small molecule from which polymer is synthesized. Poly means many, so many monomer that held together by covalent bond in a long chain. So not that you have to memorize, okay, by hook or by crook. You have to memorize most of those things, but you are lucky you are in the ODL session, and your final exam and your quiz are open book. So I can say it is no need to memorize, but I can say that you can refer the terms when you do your final exam or quiz. But at least you have to know where you can find the definitions. Okay, so that is what we call learning. It's not all about to memorize everything. Learning is about to know how to use that informations, where to find, where to refer, where to study back when you have to apply that knowledge in the real life. Okay, so uh, let's have a 5 minutes break. So I will pause this video and then I just continue. So you have right to pause this video now and have your little breaks of 5 minutes. Start from now. Okay, let's have a break. Okay, so let's continue. This is the polymer microstructure, symbol of microstructure. Okay, so as you can see here, this is the symbol of N. Okay, the subscript of N here indicates the number of times it repeats. So oh, my tablet is not on. This represent for number of repetition there. Okay, so let's say here is 2, so you will get C, another 2C, because it repeats 2 times, and then you will have hydrogen, hydrogen. So here is R, right? Okay, so what is the symbol of R here? R represents for hydrogen, chlorine, or any organic group. Okay, so in this case it can be comes from the hydrogen, chlorine, or any other organic groups. Okay, vinyl or ethynyl is the functional group CH, double bond with C with double bond C here, and then H2, namely the ethene molecules. So the ethene molecules minus 1 hydrogen atom. So this is the microstructure of polymer. So let's say polyethylene. So you will have R here is hydrogen carbon, and then you repeat how many times the microstructure the polymer is. So if it has 3, so it will be 3 times repetition of that mer here. And then if this is the PVC, polyvinyl chloride, it has chlorine atom, okay, at that R symbol here. So you will repeat that mer to how many times you want based on the number of N here. So in this case, we have 3 N here, okay. And then so on lah. Okay, that's how you write down the chemical formula for the polymer compounds here. So this is the summary of the polymers. Consists of many mers, gigantic macromolecules. Mostly these molecules are long and flexible chain. The backbone of the chain is a string of carbon atom. Yes, that's why if we have 20 N, so there are very long chains of carbon and hydrogens. Okay, so a large molecule, macromolecule, built up by repetitive bonding covalent of smaller molecules, monomers, generally not a well-defined structure or molecular weight. Okay, these are the examples of the polymer compound. So this is the polyethylene, polypropylene. Okay, why it is propylene? You see here the difference between ethylene and propylene. It has another hydrogen, three atoms of hydrogens bonded to this carbon. This is where the R symbol, R symbol. Vinyl chloride, it has chlorine atom here. Polystyrene, so this is the compound that substitute into the R here. And then this is Teflon, polytetrafluoroethylene Teflon. So how do you produce different polymer is based on what the elements found in the R here. Okay, so it also make the names of the compounds different between each other based on the R element here, organic element here. So basic structure of some polymers molecules, ethylene molecule and so on, already mentioned here. These molecules are example of the basic building blocks for plastics. Okay, bulk or commodity polymers. So all these polymers are common materials that we found in our daily life, in our daily products. So polyethylene, PVC, PTFE, and PP. So you now know the products that we use daily based on the polymers. Between them, the difference between them are based on the elements at the R symbol here, right? So maybe sometimes in the future you can produce your own new own polymer, and then your polymer will be named based on your name. Let's say Ahmad. So maybe they reward your invention of polymers to your name, Ahmad Polymer. Maybe, who knows? Okay. So that's so many formula of polymers here. I will not read one by one for you. Okay, so this is the exercise. Draw a mer structure to the following polymeric materials. So polypropylene, polytetrafluoroethylene. Okay, So the example here is shown as in these slides. So you do not have these slides in your notes, just write down. But this is just straightforward questions. You just write down from the example in this table here. Polyethylene, just write down the structure. Right? Okay, polymer structure. Okay, physical characteristic of a polymer depends on its molecular weight, shape, differences in the structure of the molecular chain, covalent chains, configuration, and strength. So these are examples of chains, different chains in the polymer. Okay, some may be found in the linear chain, as shown here, just a linear, and the branch, it has branches, covalent bonding here, and then cross link. Okay, between the chains, it has the cross link that interconnects between the chains, and also the network, as in this case. So based on this configuration, chain configuration, you can see that the least strength found in the linear chain and the strongest one found in the network chain. Okay. For the linear polymers, the repeat units are joined together end to end in a single chain and blah blah blah. So you can read by your own lah. Can also the branch polymer, you can also read by your own. I just skip these slides. I just don't want to waste your time. And finally, the network polymer is the strongest chain because of having three active or more covalent bond from three-dimensional network. Okay, so the properties have distinctive mechanical and thermal properties, okay, compared to the other chain here. Okay, so in this slide it should be have a video here, but I don't have a video to show you. And let's go to the classification of polymers. This is what we found in the early slides in the early of this video. There are three types of classifications of polymers: thermoplastic, thermosetting, and elastomers. Okay, so this is the definition of thermoplastic: linear or branch polymer. Okay, so thermoplastic must be linear. Yes, linear polymers and branch polymer. Okay. Which chains of molecules are not interconnected to one another? So the thermoplastic polymer, thermoplastic, found to have linear polymers and branch polymer. Right. Okay. So basically, thermoplastic have low strength compared to the thermosetting polymers. Because what? Because of thermoset polymers are heavily cross-linked to produce a strong three-dimensional network structure. So thermoset is the network polymer, has network polymer. So when you have the network polymer, you will have three-dimensional network structure that is very strong. So this one is strong, this one is weak strength. And for the elastomers, these are polymers, thermoplastic, or lightly cross-linked thermosets that have an elastic deformation more than 200%. So basically the elastomers are the thermoplastic here, or lightly cross-linked thermoset that have an elastic deformation. So elastomers are the thermoplastic but with elastic properties. This one. The difference between thermoplastic and elastomers has extra properties that has elastic deformation more than 200%. Okay, so you can see here thermoplastic and elastomers are sibling, adik-beradik. Thermoplastic dengan elastomers, tapi elastomers elastic lebih mudah lentur. Okay, so this is the general structure as also mentioned in this slide. Then okay, let's see the properties of thermoplastic. Because of it has a weaker chain, linear and branch chain, so the characteristic of thermoplastic, mostly they have softened when heated, hardened when cool, reprocessable, melt processability, high viscosity at processing temperature, and difficult to process. Properties: it's soft, lower thermal resistance, higher creep, higher moisture absorption. Example is the polyethylene, polypropylene, and polystyrene. Okay, in this case we have your pan, your food cup, and so on. Okay, and then we go to the thermosets. Okay, characteristic of thermoset is does not melt on heating, ease of their processing, low cost, lose their stiffness properties at the heat distortion temperature, become permanently hard during their formation, and do not soften upon heating. So example is rubbers, epoxies, polyesters, and phenolics. Okay, properties of the thermosets: harder, stronger, better dimensional stability, and more brittle than thermoplastic. So when you found the plastic that is hard and tough in our daily product, so mostly probably it is thermoset plastic. Okay, and then for the plastic here, basically where you found in packaging plastik, apa shopping mall, plastik kedai, benda-benda macam tu kan. Okay, sebab apa? Sebab dia lembut, and then dia melt, dia cair bila dipanaskan. Okay, jadi awak nampak perbezaan dia. Yang keras-keras, kita jumpa plastik keras macam kita punya plug, kita punya pinggan mangkuk, kita punya kipas, and so on. Okay, that one is the thermoset polymers, thermoset plastic. Okay, and then this is the comparison between thermoplastic and thermoset. So cost, thermoset much lesser than thermoplastic. Fiber impregnation comparably easy, very difficult for the thermoplastic. Melt viscosity low at the beginning, okay, rather high thermoplastic, and formulation thermoset is complex and thermoplastic is more simple. So let's look at the elastomer. what I have told you, elastomers is basically the thermoplastic, right? It's just the thermoplastic that have elastic deformation. So characteristic almost the same with the thermoplastic. It is soft, but it has low elastic modulus value, show great dimensional change when stressed, but it will return to its original dimensions immediately after the deformation stress is removed. Okay, low glass transition temperature. So in this case, stir until it breaks. Show great dimensional change when stressed, but it will return to its original dimension immediately after the deforming stress is removed. Dalam bahasa Melayunya, kita lentur dia mudah lentur, tapi dia mudah kembali ke bentuk asal. Itu sebab dia ada elastic properties. Okay. Types of elastomers. Okay, natural rubber and synthetic rubber. Betul kan? Kita compress ke, kita tarik ke, dia boleh berubah bentuk, tapi dia akan kembali ke bentuk asal dia. Itu kita panggil dia sifat elastik. And okay, this is the table to show you the common plastic properties. Okay, so if you want to use the material in your product design, okay, you can refer the properties of that materials based on the properties that you want to be in your design product. Okay, so this is the summary of the polymer chain. We have 4 types of polymer chains: linear, branch, cross-link, and network. So linear is the weakest one and network is the strongest one. So thermoplastic can be found have linear and branch, and the thermoset have the network. Okay, so the cross-link for the elastomers. Okay, so this is your exercise with the aid of sketches. Differentiate between thermoplastic, thermoset, and elastomers in terms of their general structure. Okay, so please do the exercises that you found in the notes, because mostly the exercises are extracted from the final past year final exam or past quiz in the previous semesters. So maybe the same question come out in your exam. I don't know, but maybe there is a possibility. Okay, at least you can study and memorize the answers from the exercise that you have done. Okay, so this is the answers of the exercise. You can pause this video to compare your answers. Okay, and that's it for this video. We will continue subchapter 4.3 in the next video. So until the next video, take care of yourself and don't forget to register to get the vaccination for COVID-19. Don't be anti-vaccine. We need you to be vaccinated to recover our country to go back to the normal conditions. Okay, Assalamualaikum, jaga diri, and bye-bye.